In this lesson, we will study the manufacture of nitric acid and ammonium nitrate. We will start first by the manufacture of nitric acid. You can see this apparatus here. A mixture of ammonia and air is passed over a platinum rhodium gauze catalyst at 900 degrees Celsius. The gas mixture flows through the gauze, which provides a large surface area for the reaction to take place, and then nitrogen monoxide and water are formed. So you can see in the equation, 4NH₃, which is gas, plus 5O2, which is oxygen gas, gives 4NO and water, H2O. So the products are nitrogen monoxide and water. Notice the symbol in the middle of the reaction. This means that the reaction is reversible. The air and nitrogen monoxide are then passed through a cooler. In the cooler, they react to form nitrogen dioxide, which is NO2. It has one nitrogen atom and two oxygen atoms. This is the equation of the reaction, where you can see that 2NO, which is nitrogen monoxide gas, plus O2, which is oxygen gas, gives 2NO2 gas, which is the nitrogen dioxide gas. Remember that our aim is to manufacture nitric acid. The nitrogen dioxide and the air are then passed into an absorption tower that you can see in this simulation here, where they react with water to produce nitric acid. The water is sprayed over many small glass beads in order to increase the surface area available for the reaction. Increasing the surface area fastens the reaction. The nitric acid forms at the bottom of the tower and then it's piped away. This is the equation of the reaction in the tower. 4NO2, which is the nitrogen dioxide gas, plus oxygen O2 plus water from the tower would give HNO₃ liquid, which is the nitric acid that is piped away. And that's how nitric acid is manufactured. And now let's take a look at the manufacture of ammonium nitrate. Much of the nitric acid made in industry is used to make the fertilizer ammonium nitrate, which is NH₄NO₃, and that's why we saw the manufacture of nitric acid in the first place, because it's involved in the manufacture of ammonium nitrate. Ammonia is an alkali, so it will undergo a neutralization reaction with the nitric acid, and the salt made is ammonium nitrate. This is how the process occurs. So solutions of nitric acid and ammonia are pumped into a mixing vessel. We got the nitric acid from the process we saw earlier in the video, and the ammonia can be manufactured by the Haber process. The nitric acid is neutralized to form ammonium nitrate solution according to this equation. NH₃, which is aqueous, the ammonia, plus HNO₃ aqueous, which is the nitric acid, gives a salt, which is ammonium nitrate, which is aqueous. This is not the end of the process. The ammonium nitrate solution is heated. Water evaporates off, leaving molten ammonium nitrate. Because the ammonium nitrate in the reaction is aqueous, so it's in a solution that contains water. That's why we need to remove water from the solution by evaporation. So now we're left with molten ammonium nitrate. The molten ammonium nitrate is sprayed into a cooling chamber. Cooling means low temperature. Air is blown in the bottom of the cooling chamber to cool the ammonium nitrate. The droplets of molten ammonium nitrate cool and harden into pellets. So now you see why we cool down the ammonium nitrate. We need them to harden and turn into pellets. These pellets are used as fertilizer. And this is the importance of ammonium nitrate, used as fertilizers for the crops.